This conference will now be recorded.
So I'll reiterate again, guys. So how does Oracle perform a full table scan or a fast full index scan? Oracle, a session has two options, either using direct path read or DB file scattered read. So it's not the optimizer which decides whether to go with direct path read or DB file scattered read. It's basically the session. It's a session which actually decides whether to go with the direct path read or DB file scattered read. So now there are few fundamental differences between both of these mechanisms. So DB file scattered read, you end up reading the blocks into your buffer cache. And moreover, this operation is a synchronous operation only. Synchronous operation. You need to understand that Oracle always uses synchronous IO when it comes to reading either the table blocks or index blocks while performing full scan. Full scan in the sense fast full index scan in terms of index, and for a table, full table scan. So Oracle always makes use of synchronous IO only. The calls that you would end up seeing are basically pre-read 64 calls only. So by default, before 11G, Oracle by default made use of DB file scattered read only while performing the full table scans. This was really a cause of concern because Oracle, due to the fact that it used to read the blocks into your buffer cache, so you need to find a free buffer or a buffer with less touch counts to replace it with. So due to the fact that you are bringing too many blocks into the buffer cache, it resulted in buffer cache flooding. This indirectly affected other operations as well, other SQL queries or other sessions as well. So starting with 12C, a full table scan can be performed, full table scan or fast full index scan can be performed using direct path read as well, but the choice is basically dependent on the cost. So we'll talk about several things. I mean, most of the things that actually come here in the next subsequent slide or set of slides. So you have to remember that with the enhancement, Oracle came up with the direct path read enhancement starting with 11G, and this is precisely the point wherein Oracle introduced Exadata also. Exadata also. So smart scans they have introduced starting with 11G. I mean 11G is is the database version wherein this is where Oracle introduced Exadata, and this is also the point wherein Oracle introduced direct path reads for full table scans as well. Full table scans as well, and even don't assume that that only the table scans, also the indexes can go with direct path read as well while performing an fast full index scan. So now coming to the direct path read. Direct path read, instead of reading the data into my buffer cache, it reads the data into the PGA. It reads the data into the PGA. So due to the fact that you are not bringing the blocks into the buffer cache, there is very minimal effect on the buffer cache or even the other sessions that are running on your database. Remember, minimal effect, minimal effect. So many people, many DBAs usually assume that during the direct path read, sorry guys, during the direct path read, Oracle will only bring the blocks into the PGA. It is not 100% accurate. This is wrong assumption. Oracle can also bring blocks into your buffer cache. We'll talk about that in the next subsequent set of slides. So for now, just remember that Oracle has the ability to bring blocks into your buffer cache even when it is scanning the segment, either be it table or index, using direct path read. And direct path reads are the ones which make use of asynchronous IO. And moreover, even before commencing an direct path read, Oracle has to perform an object level checkpoint. So I'm going to show you just in the context of IO behavior, and then we'll proceed ahead. So I have cleaned up everything. So what I'm going to do is I'm going to start loading the data into a table. And moreover, these machines that I'm working on, these VMs that I'm working on are not basically typical normal virtual machines. So I'm not running them off. This thing is VMware Workstation or VMware Fusion, but instead these are basically ESXi. These VMs are present on ESXi. So this gets as close to replicating the issues as possible in your actual production environment. So now what I'm going to do is I'm going to start loading the data into the table. So now let's see. I think this should be more than enough. Yes, 1200 MB. So yeah, this is more than enough. So what I'm going to do now is I'm going to force a direct path read. Oh bloody hell. I have been showing a wrong window all the time.
Yes, Vishnu.
Yeah, someone should explain this. So I've been scribbling all over the screen, and then finally I noticed it. Please do inform me, guys. So I think the evening session, I think I will share it. So now I have loaded the data with the table. So what I'm going to do now is I'm going to perform an SQL trace on this particular session. Select AVG of mark one from students. So here SQL trace, and moreover I'm going to perform an strace as well. Strace-p, and by default let's see what Oracle comes up with. So all the blocks are already in the buffer cache due to the fact that I don't see any weights here, and moreover my SGA is quite high, guys. I'm going to flush everything out. I'm going to flush the buffer cache and the shared pool as well, so that no blocks are present in the buffer cache. So now I'm going to execute the same query here. Let's see. So Oracle did go with the direct path read here. So in terms of IO calls, let's see the IO calls made. Can you see the IO submit wait event, guys? IO submit call. So while performing a full table scan or a fast full index scan, using the direct path read, Oracle will always make use of asynchronous IO. Now, I'm going to force a DB file scattered read. So using serial direct read parameter. Now, let's see the behavior. Let's see the behavior. So it's more than enough. So can you see the period 64 calls, guys, everyone?
Yes.
Yeah, Vishnu.
So you need to understand one thing. Why does Oracle use synchronous IO here? Why not asynchronous IO? Because you have to understand one thing here. Oracle reads multiple blocks in continuous chunks, multiple blocks that are stored in continuous chunks using a single IO call, and then basically scatters them in the buffer cache. So they call it scatters them in the buffer cache. The true meaning is completely different. True meaning is completely different. Don't assume that it simply grabs hold of few blocks and then spreads it across, something like that. So the behavior is, so here I am reading 128 blocks. On each block DBA, data block address, I apply the hash function. Once I apply the hash function, I get to know which chain I need to place it in. This is, I mean, even though the blocks are adjacent to one another, the hash function that Oracle applies make sure that the data blocks are spread across multiple hash chains. This is the true meaning saying that Oracle scatters the blocks in my buffer cache while I am performing a full table scan or a fast full index scan using a DB file scattered read. So here, until unless all these blocks are read into my buffer cache, Oracle will not proceed ahead. Will not proceed ahead. So now we are reading. So let me just grab this screenshot here. You need to understand one thing here. Preread 64 is a synchronous call until unless these 128 blocks are read. Until unless these 128 blocks are read, or this 1 MB of read operation is complete, Oracle will not proceed ahead because due to the fact that you are bringing these blocks into my buffer cache, you need to find a free buffer or any buffer that has a block with lower touch counts to replace it with. So if you are making use of asynchronous IO, you would end up bringing too many blocks and cause too much havoc at the buffer cache layer. So Oracle, instead of using asynchronous IO, in order to minimize its effect on the buffer cache while performing a full table scan, always makes use of synchronous IO calls, especially when going with DB file scattered read. Full table scans are fast full index scans. So let me proceed ahead here. So as I've explained in the previous session as well, so the serial direct read parameter acts as a master switch when it comes to the session's decision whether it has to go with the direct path read or DB file scattered read. So many TPS usually think there is no need to meddle with this particular parameter. But honestly speaking, there are several maintenance activities or several scenarios wherein you need to basically set this parameter. I'll explain them in, as we go along the course, you will find using this particular parameter to influence the session's decision very handy, very handy because direct DB file scattered read inherently has a disadvantage. So it's not just finding the corresponding free buffers in my buffer cache or finding the buffer with the lower touch nodes. It's not just this, but the presence of buff cached blocks can also alter the IO behavior as well. So I'll talk about that in the next subsequent slide. So just remember that this parameter will be very handy for you guys, especially in certain scenarios. So please be very attentive when I'm talking to this. By default, this parameter will be set to auto, guys. So I'll close all the sessions up. By default, this parameter is set to auto. This means that Oracle uses the cost model. The Oracle or the session uses the cost model to decide whether to go with a direct path read or DB file scattered read. So once you set this parameter can be set at the session level as well, and also the system level. Don't try changing this parameter at the system level to force the direct path reads. There are many books or even blogs which suggest doing this, but this is a very bad idea. This is a very bad idea. So you will eventually realize why I said that. So once you understand the true aspects in all the angles, so yeah, Vivek, wait, please wait. I'll answer that. So if you set this parameter to either true or always, remember guys, true does not necessarily mean Oracle ends up going with direct path read all the time. It is only when you use always, then Oracle will always perform the full table or fast full index scan using direct path read only. Then if you set this parameter, you don't have to use true or false. I mean, they are not handy. They are not handy sometimes because Oracle may choose not to. I mean, even if you set the serial direct read to true, Oracle may not choose to go with the direct path read in certain cases. So always go with never or always. So always go with the never or always. So when you set this parameter at the session level to either always or null, always or never, Oracle simply ignores the Oracle simply ignores the cost model, or it does not even bother to check what is the size of the table or the index and everything, how many blocks are present in the buffer cache, even though 100% of the blocks are present in the buffer cache. Oracle, if you set this to always, Oracle will go with the direct path read only. So it simply ignores the table size or even how many blocks are present in the buffer cache and everything. So it simply ignores them. Setting it to never will force the session to always perform full table scan or fast full index scan using DB file scattered read only. So can you influence this at the SQL level? Can you influence this decision at the SQL level? The answer is no, you cannot. You cannot use OPT params hint as well. You simply end up with syntax error. So you will simply end up with the syntax error. So I'll talk about the auto now. By default, let me bring up a different slide here. So by default, this parameter will be set to auto. Yes, in this case, Oracle uses several factors such as the size of the table or the index. So size of the table not in terms of MB guys. So size of the table in terms of MB size, actual size, it does not consider that. It basically considers the size in terms of blocks below the high water mark. So don't. So I can have a table with less than 100 rows, and the size of the table can be 1 GB as well. I can simply allocate more extents to this particular segment. Size eventually grows as I allocate more extents. So Oracle does not consider, I mean, Oracle does not look at the size of the table, but in fact, it looks at the blocks below the high water mark. Then Oracle uses various thresholds as well, guys. So small table threshold by default, it is set to 2% of your buffer cache, and this threshold, medium table threshold, this cannot be directly configured. You cannot directly configure it. So this is an internally set threshold. This one by default will be set to 10% always. And very large object threshold, this one defaults to 5 times your size of your buffer cache. All these thresholds come into the play while deciding whether to perform a full table scan or a fast full, I mean, index scan using direct path read or DB file scattered read. So looking at these thresholds, it also considers checks at how many blocks in the buffer cache are clean or dirty as well. So small table. So if a table is of size, suppose say 1 gig, and my buffer cache is 1 gig, and here in this case, do you think Oracle goes with, so the size of the table is obviously greater than 100 MB, which is greater than medium table threshold. So in this case, will Oracle go with direct path read or scattered read case? How does Oracle even come up with the decision? That even Oracle blog suggests that it does not go with DB file scattered read, but it's completely wrong. I'll point out to the blog as well. So you have to remember it's basically the presence of dirty blocks in the buffer cache. If the table size is greater than the median table threshold, and if you have more dirty blocks in your buffer cache, this thing actually has a significant effect on determining Oracle session's decision to go with the DB file scattered read. So even if the table size is greater than medium table threshold, and if you have too many blocks in the buffer cache which are dirty, in this case, Oracle can choose to go with DB file scattered read. So any doubts still here, guys? No. So I'm going to point out to the book. So the main point of why I am pointing out, certain blocks, even Oracle blocks as well, because you need to understand something. Don't believe anything what you see is basically true. So I'll put it in a different sense. This is the Oracle blog. So when you look at a blog written by people in the Oracle, do you 100% assume that, will you assume that this is true, everyone?
Yes.
So
Yes.
here it says when the size of the table or an index in the blocks is greater than. So it also says that vlot is, ignore the vlot in the blocks. It hasn't been used for many years, but persists in the trace for and the blocks for historic reasons. This is also completely wrong. This is also completely wrong. So I'll show you exactly now, slowly. So don't worry. I'll talk about that in a few while, in a few short while. So remember this thing. So now I'm going to show you some examples here where things work as expected and things does not. So now I have a table here. What I'm going to do is I'm going to set my SGA. My SGA size is pretty huge here. Alter system set SGA target is equal to 1 gig, scope is equal to SP file. Alter system set SGA max size is equal to 1 gig, scope is equal to SP file, and I'm going to restart this particular database. Startup force. Now, once the database is started, I'll show you a few examples, guys. So at SGA, my buffer cache size is close to 656 MB. Now, let's see the table size. Table size is 1472. So I don't want 1472. So to replicate this scenario, 650, I'll create a different table here. Create table temp as select star and students where woman less than the table size will be obviously greater than the buffer cache. So notice here, the size of my buffer cache is 656 MB, and moreover, Oracle did shrink this buffer cache. Now the target size is 612 MB. Now the size is 612 MB. The size of the temp table is close to 700 or 800 MB. So what I'm going to do is I'm going to perform an update on this particular table. So I'm going to flush everything out. So update temp set student ID is equal to student ID minus 1, where Ronum, where student ID less than. So I am basically modifying half of the data. So I have almost 50% of the blocks belonging to temp table already cached in the buffer cache, and these blocks are dirty. Obviously the size of the table here is greater than 10% of my buffer cache. 10% in the sense 60 M medium table threshold. So let me just run a query here. So I'm going to commit this transaction as well. Now the session ID is this. So now what I'm going to do is I'm going to perform an SQL case here. Select abgr from student from temp. Let's see whether if Oracle goes with direct path read or scattered read. So can you notice, guys, everyone?
Yes.
So you have to understand that even if the table size is greater than median table threshold, in the presence of more dirty blocks, Oracle will always go in the presence of more dirty blocks. Oracle can go with DB file scattered read. But what if the table size is larger than VLOT or very large object threshold? So very large object threshold by default will be 5 times my buffer cache. So let me just show you that here as well. So here I'm going to insert basically bring this. So what is the size of my SGA? Size of my buffer cache? Buffer cache size is 608 MB. 608 MB into 5 actually translates to somewhere around close to 3 gigs. So what I'm going to do, I'm going to increase this particular table size. Insert into 10, select star from 10. Right. So I'm going to increase it twice. Let it run. It should not take huge time. Yes. So the table size is obviously 1.5 gigs now. So instead of waiting, it should hardly take a minute. Yeah. Yeah, it's taking huge amount of time. I don't want to do anything. So let me just load the table. It's way more faster. Now the rollback will go on.
Or you can reduce the cache size.
No. I don't want to meddle with that. Because so okay, that's all right. Let it recover, and anyhow, this thing will end up creating the students table. So you need to make use of this thing, guys. I'll teach you regarding what all these are slowly, so that you get to see. So I'm loading the students table here. I'm creating the students table and then loading it with data. So one thing you need to remember here, I have SQL ID here. So let me show you the SQL ID as well. So looking at this SQL statement, how many rows can you insert using this SQL statement? Guys? Hey, previous batch guys, don't answer this query. So the statement is a regular statement, right? Hello?
Single,
Yeah.
you said.
Single row.
Single.
So how many of you think actually it's single row?
Yes, it is single one, sir.
No, guys, that is completely wrong. That is completely wrong. So don't assume that. So I mean, the table size is actually a lot greater now. Okay, I'll explain this in a short while. So here I have stopped the workload as well, guys. Vivek, can you put your place your call on mute? So now I'll show you the how many times it has executed this. Everyone, this insert statement.
100
Can you
times.
notice?
100 and
100 times,
108.
108 times. How many rows did it insert? If it is one-on-one, I mean, if each execution actually resulted in inserting one row, I should have only 108 rows
One
in
or
my table. So now let's see the number of rows in my table. So isn't this completely way different from what you actually think? So you need to understand one thing, especially when you are dealing with bind variables. If an application is inserting a executing a SQL statement that to either insert, update, or delete, whatever it is, by default, DBAs assume that each execution will end up updating only a single row, but that is completely very bad, wrong. I mean, you should not assume things, guys. So application, it's purely up to the application to use whichever API they want to. So I'll try to explain this slow. I mean, in the next section, after a few certain bit. But for now, just remember that. For now, just to remember that executing in a DML statement. I'm talking about DMLs only, especially if you use bind variables only. And 99 or even 100% of the applications these days, developed these days, make use of bind variables only, not the literal values. So now I have the students table here, which is of the size 3.5 gigs. 3.5 gigs or something like that, and my final buffer cat size is 604 MB. Obviously, this is greater than the vlot threshold. So vlot threshold, this is not hidden, very large object threshold. By default, the value is set to 500. It means that 5 times the size of my buffer cache. 5 times the size of the buffer cache. So now I'm going to execute the same query here. So so what I'm going to do is I'm going to perform an update statement or whatever it is. So update student set student ID is equal to student ID minus 1. Here student ID less than. We saw there were 8.8 lakh rows. So I'm going to update, suppose say 2 lakh rows or even 1 lakh rows, whatever it is. So maybe I should have connected using my username. I'm going to update, suppose say 1 lakh rows, almost 1/8, close to 300 or 400 MB. So now, once the update is complete, what I'm going to do is I do have dirty buffers in my buffer cache here. I do have dirty buffers in my buffer cache. So due to the fact that I have modified the data blocks. Now, once this DML statement is complete, or once this DML statement has finished execution, what I'm going to do is I'm going to run an SQL trace. Now, you have to remember one thing. When if the size of the table or the index crosses very large object threshold, or indirectly put, if the size of the table or the size of the index in terms of blocks below the high water mark crosses, or if the size exceeds 5 times the size of my buffer cache, regardless of how many dirty blocks are present in the buffer cache or how many blocks are present in the buffer cache. Oracle always goes with the direct path read only. Here, you would be surprised. You will certainly be surprised to see that Oracle will go with. So let's see. So now I'm going to issue a query, guys. Select AVG of smartphone from students. Let's see. Yes. Can you notice this, guys, everyone?
Yes.
So you need to understand one thing. So what if the statistics are not up to date? What if I have stale statistics? So let me show you the same behavior here. I mean, don't, I'm explaining this in a different way. So don't take this as a hard coded rule, because there are certain things that also meddle up. Even the statistics and also have a certain part. I'll talk about direct read decision statistics driven hidden parameter in the next subsequent slides. I'm just trying to introduce that concept here. So what I'm going to do now is I'm going to set the statistics for this particular table here. So what I'm going to do is I'm going to extract the statistics for this particular table and then manually set them up. So so one moment, yes. There are so many scripts here. I do at times, yeah, basically lose track of it. So here, frankly speaking, do I have statistics on this particular table? I don't think so. So let me just gather the statistics for now, and I'm gonna medal these statistics out. Yes, exec dbms underscore stats the table stats. So I have more CPUs allocated to this box, guys. So that is the reason why I'm using 16 this thing. I have 8 CPUs allocated here, 8 vCPUs. So let it complete. So once the statistics job is complete, what I'm going to do is I'm going to set the statistics of this table manually. I'm going to set or medal with these statistics manually, and then let me show it. So LSLTR good stat. So yes. So these are my statistics here. These are my statistics. What I'm going to do is I'm going to meddle with these statistics here. I'm going to modify the statistics of this particular table. So exec dbms underscore stats or delete table stats Vishnu comma students. So your statistics delete table stats. So let me just modify this and then I'll try to explain the things in a very different way. So now there is the text editor. So the number of blocks, I am basically reducing it by many things. Number of rows is okay. I'm going to reduce the number of blocks here. So I want to even reduce this thing out. So now I'm setting the statistics of the students table manually. So I'm just trying to show you what would happen if the statistics are stale and if the dynamic sampling does not kick in. There are many scenarios wherein the dynamic sampling does not kick in. So let me flush the buffer cache on the shared pool. Now I'm going to run a query here, guys. At active, this is my SID. So I'm going to perform an SQL trace here on this particular session. Select TVG of mark1 from students. So select TVG of mark1 from students. Let's see. So one moment. I still think that there is some other thing coming up. Once I set the statistics manually, Oracle should eventually go with uh, Oracle should go with this thing. Okay? I mean the scatter tree. So I need to basically set everything. I need to set these as well. So finally, at one point in time, you would end up finding. Can you see, guys? Hello?
Yes.
Even though the size of the table is greater than the VLOT, or even though if the table or the index size is greater than the VLOT threshold or very large object threshold, in the presence of stale statistics, Oracle can go with the wrong decision. Oracle can go with the wrong decision. That too, the session can end up making a mistake here. So you need to basically understand that and the statistics also play a role in the Oracle sessions decision to go with either the scattered read or direct path read. So here I should have mentioned the statistics as well. So you don't just assume that if the table size is greater than 10% of my buffer cache or medium table threshold, Oracle always goes with the direct path read. It's not necessarily the case. If you have more dirty blocks in your buffer cache, even though the table size is greater than median table threshold, Oracle will always go with the DB file scatter read in the presence of dirty blocks. So I'll put things in a very simplistic way, very simplistic way, so that you get to see the fundamentals more precisely. So let me just move the slides here. Let me just get to the next slide. Slowly you will understand. So this thing we already know. Once you set this parameter to never, serial direct read to never, Oracle always uses DB file scattered read only. You are bringing the blocks into the buffer cache. This is more dangerous. This is more dangerous. If you set this parameter to always, you always end up performing full table scan or fast full index scan using the direct path read only. So the next slide. So can you basically affect the decision? Can you actually alter the decision at the SQL level? SQL level. No, you cannot use this particular hint. These are not compatible. These are not compatible with each other. These are not compatible with each other. So I'll talk about each of these parameters closely. So even before proceeding ahead, let me just copy two slides here and then try to explain. Then we'll proceed ahead. How the cost model actually comes up. So you have this particular parameter set to true by default, direct read decision statistics driven. So if this parameter is true, then your session, instead of relying on segment header to see the number of blocks below the high water mark, it uses the data in the statistics. So instead of getting the data from the segment header block regarding the number of blocks below the high watermark, by default, due to the fact that direct read decision statistics driven is set to true, Oracle will always makes use of the statistics. So your session will always depend on, one moment guys, your session will always depend on the statistics to determine whether to go with the direct path read or db file scattered read, due to the fact that this parameter will be set to true by default. So let me just show you that parameter as well. Direct read decision statistics driven. So when a table is performing, when the optimizer comes up with a full table scan, Oracle, if you have this parameter, by default, this will be set to true. Oracle will blindly believe that the statistics are up to date. And then it goes with, it ends up rather than looking at the segment header, it's the session just decides based on the data that is present here itself. So make sure you always have up-to-date statistics. Missing or stale statistics can cause issues. What if the statistics are not present at all? What if I delete my statistics? So I just showed you, I have set the statistics manually here. So let me just show you that example, and then I'll delete the statistics and then we'll go ahead. So now this is my set SPID. So I'm going with the DB file scattered read itself. Yes. And what now? I delete this statistics. I'm going to run the same statement again. Let's see. Can you see, guys? So if your statistics are not there, in that case, your session actually depends on segment header block to decide to get the details regarding how many blocks, what is the table size in terms of blocks, or how many blocks are present below the high watermark information. So your stale statistics can really mess things up, especially if you are creating a table and then loading it with data. Always make sure post the data load, you gather the statistics. If you do not gather the statistics, things can get really ugly. If you are creating a table using create CTAS statement, CTAS or create table as select, in that case, Oracle by default, starting with 12 calculates the statistics. You will not see any issue regarding this decision part. But if you are creating a table manually, create table, and then inserting the data into the table using the insert statement, whatever it is, if your statistics are not up to date, then things can get really ugly. Things can get really ugly. So finally, if your statistics are not present, then session can read the segment header block to determine the decision, regardless of whether the segment is a table or index or partition or sub-partition also. Don't just assume that, for even though if I'm reading a sub-partition. So what if I am trying to perform a full scan, full table scan on an index table partition or a sub-partition, or fast full index scan on a index partition or index sub-partition? Even in these cases, if you don't have these statistics, Oracle will read that particular segment's header block and then decide. So now that you know from the statistics part, now let's see. If your table or the index size is always less than or equal to small table threshold, then 100% of the time Oracle will come up with scattered read only. So now let's talk about very complex scenario. I have 500 gigabytes of buffer cache. 2% translates to how much, guys? 10 gigabytes. So reading 10 gigabytes into my buffer cache, especially in environments wherein I have huge buffer caches, do you think it is good?
No. No.
So we cannot say, guys. It actually depends on how busy the blocks in the buffer cache are. If you have more dirty blocks, things can get really ugly, because since you are bringing a block into the buffer cache, if you have more dirty blocks in your buffer cache, eventually you will end up triggering the database writer to write these blocks into the buffer, or write these dirty blocks into the disk as well. So in these cases, you will end up with free buffer weights. So you need to understand several things. So especially when you are dealing with environments wherein you have huge buffer caches. So the maximum I have seen is close to 800 gigs as my buffer cache is. 800 gigs. 800 GB as the buffer cache size. So in these environments, we had to basically tune these particular settings based on my workload, based on the activity on the database. So you need to basically be aware of these things. So once the table size or the index size is greater than very large object threshold, Oracle by default goes with the direct path read only. Here, if the statistics are not up to date, then you may end up seeing DB files scattered read also. Don't take this as a universal rule, because indirectly you are depending, your session actually depends on your statistics, but due to the fact that your statistics are stale, oracle can end up oracle will end up going with the db file scattered read. So be aware of this thing. Don't take this as a universal rule altogether. Don't take this as a universal rule altogether. But what if the size of the table is greater than small table threshold and less than medium table threshold? So what if the size of the table is 2%, greater than 2% of your buffer cache and less than 10% of this size of the buffer cache? In this case, almost 95% of the time, 90 to 95% of the time, Oracle can go with DB files scattered read only. Yes, 5 to 10% of the time, even if the statistics are up to date, Oracle can also choose to go with direct path read also. So the algorithm is too complex. That's the reason why I'm just trying to make it as simple as possible. So, there are too many internals. There is no point in learning those things. So, if the table size is greater than small table threshold and less than medium table threshold, 90 to 95% of the time, Oracle can go with DB file scattered read only. 5 to 10% of the time, Oracle can also choose direct path reads. Once the table size crosses medium table threshold and table or the index size crosses, so the algorithm is completely different for tables and indexes, guys. So medium table threshold, small table threshold, observe the table here. Observe the keyword table here. These applies only to the tables, not indexes. By default, many DBAs assume that this parameter is relevant for both tables and indexes. No, these thresholds are only relevant for tables only, not indexes. Only the very large object threshold applies to both tables and indexes. So here, if the table size is greater than median table threshold and less than VLOT, then 90 to 95% of the time, you would end up seeing direct path reads. 10% or 5 to 10% of the cases, that is what I have explained you before. I mean, if you have more dirty blocks in the buffer cache as well, even in those cases, Oracle can go with DB file scattered read even if the table size is greater than median table threshold. So all these thresholds, now that I have explained, small table threshold and the median table threshold, these things are only relevant for tables only, not for indexes, not for indexes. For indexes, I mean, if you have to perform a fast full index scan, the choice of whether to go with the direct path read or scattered read is dependent only on this particular hidden parameter only. If your object, if your index size is less than VLOT, then Oracle will go with DB file scattered read. You need to be especially very careful in environments you have where you end up performing fast full index scans. These are really dirty because, so let me just show you the table here. So what's exercise? I have the table here, guys. So due to the fact that the data is very high, so what I'm going to do is not table temp create index my name underscore idx on students of in parallel of 8. So let me just create it using parallelism. Yes, I don't want it to run forever. So, yeah, it's running. So it's still running. So let me see directorate. I think it has already finished the full scan part. So once that is done, alter index name underscore IDX. No parallel. What I'm going to do is I'm going to even modify alter tables too. So once the index is complete, I'm going to simulate an index fast full scan. So let's see. When I'm creating the index, by default, the index statistics will also be gathered as part of the create statement itself. So let it run. I think it is basically in the sorting phase right now. It is basically in the sorting phase. Now, once the sort phase is complete, my index is actually index creation will be actually done. So hopefully it should complete in 15 seconds. So let's hang on. So any doubts in the meanwhile, guys?
Yes,
So
Vishnu, so the first case where, okay, go ahead.
yeah, tell.
So in the first case, when, in the case of small table, when Oracle goes for scattered read only, is there a way to force, or is it not beneficial to force Oracle to go for direct path read?
Yeah, even if the table size is less than small table threshold, you can force Oracle to go with the direct path read itself.
Okay, but
So
we cannot play with the system level parameter, right? So only for the session level,
session level,
let's say we are
yes.
doing some,
Yeah,
we can,
session level you
okay.
can. Session level you can. So I'll show you that again as well. So yesterday evening I did show, but now let's see here. So one moment. This is my CDF. Let me show you the plan first. So explain plan for select star from table dbms underscore explain dot display. So I'm going with an index fast full scan here. The statistics of this particular index are already good due to the. So I'll do one thing. I'll even gather the stats. So so one moment, guys. I don't want this data to be dumped into my PGA for future demos as well. So I'm going to increase this particular machine's memory. Shut immediate exit sudo init of 07. Let me increase the size of the memory allocated for this box. So for this VM. So once this is down, I'll basically increase the memory. Database is dismounted. Now let it take down. Yeah, the machine is going down right now. So let me increase the size of this virtual machines. Practice SSD. Now the settings. I have 16 gigs allocated to my RAM. So I'm gonna use it to. I'm gonna increase it to suppose 48 gigs. 48 gigs. I don't want our demos to actually slow down. So that's the reason why I'm increasing my RAM here. Refresh, yeah, 48 gigs. Yes. Now I'm starting it up.
Vishnu, I have a doubt here.
Yeah.
So since you are performing the average of a student column on one of the column which is having the integer value, whereas in the lob and blob we perform the lob averages. So does it applies in the same case, or like it behaves in little different?
Lob and blob by default will go with direct path read only. Lobs, unless you have caching enabled, the lobs by default will go with the direct path read only. Lobs are not subject to caching
Okay, that means where by
default.
default no thresholds will be applied.
Yeah, lobs directly will go with the lob segments by default go with the direct path read unless you have enabled caching. And moreover, enabling caching on the lob segments is a pretty bad idea. Let me just see the changes here. Yes, I have allocated 16 GB. Yes, now alter system. Once I start up, for instance, alter system set PGA aggregate target to suppose say 32 gigs. Alter system set PGA aggregate target to suppose say 24. Scope is equal to SP file. Show parameter PGA aggregate limit. So I don't want this PGA aggregate limit to be present here. So I'm just start up force. So what I'm going to do is I'm going to gather the stats on this particular index, and more precisely, the people may actually think that the statistics may be wrong, but it's not the case, guys. So just to demonstrate that, I'm going to gather the statistics here. How to gather stats. So it will gather the index statistics as well. So let it run. Let me see if it is actually dumping the data into my temp table space. So it's not. Yes, that's a good thing. So yeah, it's completing faster. Once this is complete, I'm gonna do one thing. So the SGS size, my buffer cache size is close to 592 MB. So obviously the index size is greater than my buffer cache and basically less than, see here, okay, the name underscore index is pretty large here. So I'm gonna meddle with this buffer cache as well. Alter system set SGA target is equal to 1500 M scope is equal to SP file. Alter system set SGA max size is equal to 1500 M, so is equal to SP file. Startup force. So this is a VM, guys. So that is the reason why I'm basically using startup force. In your environments, don't do that unless it is a dev environment and it can be discarded. So now my buffer cache size is close to 1 gigs I mean, is basically greater than 1 gigs, and the index size is close to 3.5 gigs. You have to understand, for indexes, if you have to perform a fast full index scan, there is only one limit that actually applies for indexes. That is the VLOT threshold only. If the size of the index is less than VLOT threshold, then Oracle will always goes with the DB file scattered read only. It is only when the index size is greater than VLOT threshold, then only Oracle will go with direct path read. So now, obviously here, looking at the details, my index size is less than the VLOT threshold, that is 5 times the size of my buffer cache. So let me just show you the scenario. So here, this is my FPID. So I'm going to perform a SQL trace here. Now select min of length of name from students where name is not null. So here, observe this thing, guys. Name is not null. This has not null constraint has a profound effect on Oracle's optimizer decision to go with scattered read, go with the index fast full scan or full table scan. So you have to remember that as well. So the not null constraint also has a certain effect on optimizer's decision whether to come up with the full table scan or fast full index scan as well. For now, since we are not dealing with nulls, I'm going to skip it for now. So we'll be dealing with nulls, especially when we are dealing when we are talking about indexes. So I'll talk about that during that time. So what the hell happened? So I did restart the database before at active. So this is my SIT. This is my SPID. SQL trace. So now let me run this query here. Let's see. Can you see, guys, everyone? Even after the statistics are up to date, Oracle, by default, when you are going with a fast full scan, Oracle will always goes with fast full index scan. Oracle, if the index size is less than VLOT threshold, Oracle will always goes with the scattered read. You need to be very careful, especially in environments wherein you have more index fast full scans, because since only the VLOT threshold happens, suppose say if my buffer cache is 500 gigs, and if the 5 times the size of my buffer cache, 2.5 TB, if my index is close to 2 TB also, in this case, doing a fast full scan using DB file scattered read, do you think it will actually help, or does it even make things even way slow, especially for indexes, guys?
No.
Everyone, it makes things even way worse. So especially when dealing with environments wherein you have huge buffer caches, the default value of VLOD threshold can be deadly in cases if you have fast full index scans. For indexes, only this threshold applies. Now what I'm going to do is I'm going to reduce my SGA here. Alter system set SGA target is equal to 1G, scope is equal to SD file. Alter system set SGA max size is equal to 1 gig, scope is equal to SD file, and SS startup force. I'm gonna start this database, restart the database, and now finally what I'm going to do is I'm gonna perform the same. I'm going to execute the same statement here. So let me show you the SGA sizes on the at SGA. The size of the SGA buffer cache is now close to 656 MB. It is even way more. So I usually work when I'm practicing. I usually have SGA size set to 800 MB, guys. So regardless of how much memory I have on the boxes, on my Mac or even in my laptops, wherever it is. I mean, I always go with 800 MB only so that I get a consistent behavior when I am working or practicing. So even if my desktop here, I have 64 gigs, I usually go with 800 MB only for my buffer cache. Even in an ESXi environment here, I have close to 64 gigs. This is a different box altogether with a Xenon processor. Even in these cases, I usually go with this thing only. So practicing while learning performance tuning, you don't have to go with huge environments. In fact, I'll tell you, when I'm working on, when I was preparing for OCM exam, 11G OCM exam, the system I used was basically this thing is, the system that I used to prepare is basically this thing. So I don't know why I'm actually not able to bring this here. So let me just, what the hell? So this is the problem, okay. So this was the system that I used, guys. Acer AOD 657. So this computer was basically not even a Celeron processor. It had Atom processor. It had Atom processor with just 2 GB of RAM. Sorry, I upgraded it to 2 GB. So this had only 2 GB of RAM. This system I basically used when I was preparing for 11G OCM. You don't require insane hardware. So it's just waste of money, it's just showcasing stuff. So that I have this much, that much, something like that. It's basically it's not your use anymore. So now coming back at SPA, then my buffer cat size is 424 MB now. And obviously the index size is larger. The index size is larger than the vlot threshold. So now I'm going to perform an SQL trace here and then show you the benefit. SQL trace. Can you notice here, guys, everyone? Hello?
Yes, we can see.
So vlot. So you have to remember for indexes, the sessions decision to go with direct path read or DB file scattered read. Only this parameter applies. So now, after listening to everything, after looking at this, so can you say that this information is wrong completely, guys? Yeah. Can you say this is wrong, everyone?
Yeah, Vishnu.
So don't trust any document, guys, even if it is Oracle documentation or Oracle, even by the prominent authors also. Don't trust anyone when it comes to learning performance tuning until you test it manually and then see it. Don't actually trust anything, even a book or a blog or anything, because why I'm saying don't trust is, when you are troubleshooting a performance issue, you could end up seeing. So over the course of this performance tuning course, you will find several scenarios wherein you end up getting a particular weight event under a certain circumstance or a certain condition, under only certain scenarios only. Under a particular scenario, you end up seeing this particular weight event or particular behavior, and then you put it in the blog saying that this is what I've got and this is how I resolved. Reader, when you are basically reading that particular blog or even a document or something, you your viewpoint is restricted only to this particular edge case only. There could be several edge cases wherein the things can come up. So you always assume that this thing is only true. This is the only reason wherein Oracle will come up with this particular wait event or particular behavior. So don't just when you read a particular block, just add the information into your knowledge repository saying that this is one of the reasons Oracle comes up with this thing. So not always. You always have this particular thing here saying that not always. Then it is only in these cases you learn things more precisely. So let me just go ahead. So I did explain many things here. Let me just fly through the slides. So here, small table threshold actually is specified in the number of blocks case. So SS not hidden small table. Small table threshold by default will be set to 2% of your buffer cache, and this value is always specified in the number of blocks here. Number of blocks here. If the table size is less than 2% of your 2% or even equals this thing, Oracle will always goes with scattered read only. Even for indexes, it goes with the scattered read. But for indexes, VLOT threshold only applies, not small table threshold. So that is the reason why I just specified here to make sure you learn this over and over again. So you have to understand materialized views are also tables. IoTs are indexes. Index organized tables are basically the primary data structure of an IoT is an index. You should technically call an IoT as an index, not a table. Just because it is named index organized table does not necessarily mean it is a table. The primary data structure of an index organized table is basically index only. So I have seen people meddling with this particular parameter, especially in Exadata, to force the smart scans or cell offloading. This is a bad idea, guys. This is a bad idea. You will eventually learn why it is a bad idea in the next subsequent slides or as we go on this particular session. So you have to remember in Exadata environments, not always you should not always depend on smart scans. Inherently, that has more side effects. If you have to perform a full table scan or a fast full index scan using the direct path read, forcing Oracle to perform a smart scan even before the smart scan or the direct path read commences, Oracle has to perform an object level checkpoint. We'll talk about that in the next subsequent slide. So don't meddle with this parameter. I mean, there are many side effects. So we'll talk about them in the next subsequent. We'll talk about them in slowly as we progress. So medium table threshold by default is set to 10% case. This is an internal threshold and it cannot be modified. It cannot be modified. You can basically look at all these things, whether how Oracle came up with this decision and everything, setting a particular event. So you have this. How many of you have gone through the link, guys? 10.10.1.20/cgi-bin/index.cgi. So how many have you gone through this interface till now?
Yeah, I have gone through.
So let me see.
Yeah, Vishnu, I have opened.
So give me a minute here. I'll just try to show that. So I think I have configured these machines recently. So let me just show you the interface here. I'm going to close all the sessions here and finally open up a small session. Now, how do I basically see the decision? 192.168.0.20/CGI-bin/index.cgi. So this is the interface you get. I still have to develop it because I don't have the time to develop. So in the trace, you have the full scan decision part. So just click on submit. Which username? Submit it again. So this is the user now. I'm gonna enable the tracing here. Now select AVG of Mark 1 from students. So here, this trace will give you the details regarding the Oracle decision. See here, the table, the decision is direct path read due to the fact that the object size is greater than VLOAD threshold. Try making use of this, you know, full decision. I mean, Oracle's full scan decision tracing. I think the event that you have to set is NSMTIO. So once you set that thing in the this thing event using the Aura digger, you can basically see how the Oracle came up with the decision and everything. CGI bin /search. So I think this is the event that you have to set, guys. Once you set this event at the session level, you can basically see how the Oracle and what all Oracle did consider, what all factors did Oracle consider and how Oracle came up with the decision and everything. So try experimenting, you will get to see the things more clearly. So median table threshold, if the table size is greater than 10% of your buffer cache, this is an internal threshold. This is an internal threshold. You cannot basically set this. This is by default set to 10%. This is by default set to 10%. You cannot change it. You cannot change it. So here, this is for some other internal query recursive call. This is for some recursive call. So don't, this is not directly related to the table that we are talking about. So just remember guys, MTT threshold is close to 5597 here. So it is basically by default set to 10% of your buffer cache. This cannot be directly set. So the parallel execution, if you are using parallel execution and Exadata, if the table size is greater than median table threshold, there are several other internals that come into the picture. So you can basically make use of this particular event and then see the behavior more closely. So if the table size is specifically between small table threshold and medium table threshold, this statistic will be incremented. This statistic will be incremented, system level statistic. And if your table size is greater than median table threshold and that the below threshold, then you will end up seeing this statistic being incremented. So at the database level, you have this particular view. Select name value. Table spans short and long. So you can basically see how many times the Oracle is coming up with how many times the Oracle has performed a full table scan and what are the sizes of these particular tables. I mean, whether they fall under the small, whether they fall under this category or under this category. So you can basically view at the system level itself. These are handy in environments where you have to check how many full table scans are done, but you have to remember even for data dictionary tables, these statistics get incremented. So don't just assume that it's just the application workload altogether. So I just shown you in a case wherein even if the object size is greater than median table threshold, Oracle can come up with DB file scatter rate. And in this case, due to the fact that I have more dirty blocks in my buffer cache, Oracle came up with a scattered read decision. Now, very large object threshold. Remember guys, very large object threshold, by default, the value is set to 500, meaning that 5 times the size of the buffer cache. If you set this value to 100, it means exactly the size of the buffer cache. This is the parameter. This is the only parameter that applies, that a session considers while looking at fastful index scans. For indexes, this is the only parameter that applies. For tables, small table threshold, medium table threshold, and very large object threshold also matters. So that is the reason why I highlighted this in red here. So if you have environments wherein this is a hard-coded rule base, this is a hard-coded rule. If the index or the IoT size is less than the VLOT threshold, Oracle will always goes with the cached read. If the size of the index or the IoT is greater than VLOT threshold, Oracle can go with cached read as well, provided that the statistics are not up to date. So that is the reason why I didn't specify this thing as a hard-coded rule here. So if the table or the index size is greater than VLOT threshold, I mean by default, Oracle goes with the direct path read only, provided that the statistics are up to date. So you have to see the significance of statistics also in this in this particular decision. So now we will move ahead. So what all parameters? Now that we have seen, so we have seen only a certain aspect till now. So let me just bring it here. Let me just bring it here. So what all have we seen till now? So we have seen the factors that contribute to the decision. So that indirectly. So here, optimizer read count, optimizer index. So how many of you are 100% aware of these fundamentals, guys? These parameters, how do they influence the cost? How many of you are aware? Except the first batch people.
Not me.
So you have to remember these things play very
Increasing those
significant. Raj?
Yeah, having a
Well,
value
it
greater is
considers
actually
So one by one, guys. Raj and Nilesh. Raj, please answer. Please say.
I think increasing the value, I mean, close to 100, I mean, that actually uh, tends towards full table scan.
So I'll talk about these things when I'm talking about indexes. So this will have a drastic impact. So very drastic impact on the cost estimates. So I'll talk about this in the indexes session. So I'll precisely show you the places. How does the costs actually differ as well? So please, I mean, remember that, these things are very dangerous. Don't meddle with these parameters until unless you know 100% regarding how optimizer adjusts the costs. So I'll explain them very closely. So there are many websites or blogs that says that use the average wait times of DB file scattered read and then DB file sequential read average wait times and then calculate this value. That is bullshit, guys. So I'll basically explain how things actually work internally. So please be patient till the time. So while I'm talking talking regarding the indexes, I'll talk about this particular part. So please be very patient. These are parameters which can actually swing your plans insanely. So please be aware or make sure that you don't meddle with these parameters unless you know exactly what you're doing. Even in environments such as Siebel or some vendor applications, they actually recommend setting this particular value. That is completely wrong. Even the DBAs or the architects who are sitting there are dumb guys. So I'll try to explain that in a very close manner in the next set of, as we go along this course. So till now we have seen these parameters which contribute to the decision part. Now, what all factors affect the performance? We'll talk about that thing, guys. So we'll start with discussing IO. We'll start with this thing and we'll wind up for the session since we have only 26 minutes left. So discussing IO parameter and file system IO options parameter. By default, discussing IO parameter will be set to true. So file system IO options parameter is only relevant if your data files are sitting on file system only, not on ASM. If you have your data files on ASM, then file system IO options does not have an impact. So even if this parameter by default will be set to true. So when it comes to the asynchronous IO behavior of the database, this parameter acts as a master switch. So if you set this parameter to false, Oracle cannot use asynchronous IO regardless of the file system IO options. Oracle cannot use it. So this acts as a master switch. In environments where you have ASM, file system IO options, the default value to none does not actually influence the asynchronous IO behavior. You have to remember file system name itself says file system IO options. It's not a disk. It's not disk. In ASM, you have the data files on. And if you are using ASM as a storage, you don't have a file system here, which is exposed to the operating system. So you have to remember this. So this acts as a master switch case. It can, if once you set this to false, regardless of the file system IO options, you will not use asynchronous IO. So by default, this parameter will be set to true. So frankly speaking, there is no need to touch this parameter. By default, this is set to true. Leave it as it is. So now file system IO options. File system IO options, you have several values, guys. So the none value is the default value. None value is the default value. The file system IO options parameter does have a significant impact on your performance. If you do not set it to set all, if you do not set it to set all, even for index, if you have this default value set to none, so in this case, Oracle will always make use of synchronous calls. So this can have a dramatic or drastic impact even for index scans because Oracle has several optimizations such as prefetching, batching, these things come into the picture while performing index range scans. Oracle has the ability to read multiple blocks which are stored at different locations using a single IO call, making use of the asynchronous IO. If you set this file system IO options to none, by default, if you have, you rely on page cache, but what if you have to bring the blocks from the disk? In that case, you would actually end up issuing period 64 calls, which are synchronous calls that will actually reduce your performance. So give me a minute, guys. Let me drink some water. So you need to be very careful regarding this particular, even if you have this default parameter set to none, don't go and then directly set it to set all. This will have a drastic impact as well. So now let me start with the none, guys. So let me close up everything. Let me show you the behavior. I'm going to run a small workload. So SS alter system set file system IO option. So even before that, create P file from SP file. I want to save this thing first. So now create. So not needed. Alter system set file system IO options to none. So this is the default value, guys. This is a static parameter. So startup force. So what I'm going to do now is I'm going to simulate a normal workload here using a full table scan. So I have the students table here, and moreover, let me just flush the buffer cache. Sorry, file system buffers, or you should basically call it as the page cache, guys. Page cache. Don't call it file system buffers. I mean that is not the proper term to use. You should always call it the page cache. So you should always call it the page cache. So now I'm going to start a small load here. So the code is available with you also, guys. Please observe what I'm doing. That is the reason why I'm showing you the code as well, so that you tomorrow can simulate all these issues. So home, not set size. So I don't have an index on Mark 4 column. I'm going to create the index. Once the index is created, I'm going to run a random workload, guys. Let's see in terms of IO behavior. Okay. Now let me run a small workload here and sar-d1, and parallelly in a different window, I'm going to run sudo IO top as well. Now let me run the workload here. Let's see. Let's see the behavior in terms of IO. So I am running the workload here. I'm running the workload. The workload is still running. So now let me show up a new window. Let's see the activity at the database layer. So if you notice, there are many SQL queries. So I'm going to bring this here down. So there are many SQL queries that are reading the data, they are reading the data from the disk. But if you look at from the disk level, the statistics, I am not even reading a single block, because all the data is cached in my page cache. So regardless of whether if you are reading a particular block or set of blocks using an index scan or a full table scan, so be the operation, let the operation be, I mean, regardless of the type of the scan you are making, even though you are making an index scan or a full table scan, Oracle, I mean, if you are setting this parameter or leaving this parameter to null, Linux will always cache the blocks, or the operating system will always cache these blocks in the page cache. So it does not necessarily mean an index scan or a full table scan, regardless of the scan, or I mean the operating system will, if you are reading a block from the disk, it considers the possibility that you will end up reading the same block again. So it ends up storing it in the page cache. So here you have just seen an index range scan here. So what I'm going to do is I'm going to show you the explain plan as well. At explain underscore cursor, at explain underscore cursor. So this is an index range scan. Now what I'm going to do is I'm going to simulate a full table scan behavior. So I'm going to simulate a full table scan behavior. Instead, I'm going to use mark 3 column here. Mark 3 is not indexed. I'm going to run the same thing here. I would end up making direct path read. So I'm reading from the disk. If you look at this particular wait event definition, it says that you are reading the data from the disk, but not necessarily true. Here, I am reading the data from the page cache itself. You need to understand, regardless of the scan, if you are reading a set of blocks or a block or set of blocks, if you have this file system IO options parameter set to none, by default, they will be cached. So you are reading the read. You are now you are seeing the reads, guys. So you are, due to the fact that I have flushed my file system buffers, you are looking at the scans right now. The you are looking at the data being read from the disk. So slowly, eventually, now can you notice the data is brought into my page cache? So that is the reason why I am not seeing any reads. So now I'm going to show you in a different way. So here, can you see the increase, guys? Page cache. Can you see the increase?
Yes.
So regardless of the scan, be it an index scan or a full table scan, if you are having this file system IO option set to none, by default, Linux will make use of the page cache to the full extent. Linux will use, or the operating system will make use of the page cache to the full extent. Suppose say if my buffer cache is 8 gigabytes, and if I have, suppose I mean the total memory allocated to my box, suppose say it is of 48 gigabytes. In this case, Linux has the ability, I mean, if you set this parameter to none, you can see the page cache increase to even 32 gigs also, or even 40 gigs as well. So if you have more memory allocated to the page cache, that is a clear indication that you are not using the file system IO options to, the file system IO options is set to none. So Oracle, the operating system, when you are reading a block from the disk, it always considers the possibility that this block will be read again. So it caches the block in the page cache. Even if you are writing the data to the disk, even these writes are written into the page cache also. Don't assume that the page cache will contain only the clean data or the clean buffers. So you will, if you are having an in production environment with file system IO option set to none, your page cache can also contain the dirty pages. What if the power goes? What if there is a power outage, or due to some certain situation, the server goes down? In this case, the contents of my page cache are lost altogether. In this case, you have to remember, due to the fact that Linux can also have dirty pages in my page cache, these writes will be lost. So this is where you end up seeing corruption also. So you need to remember, these page cache can also hold dirty pages as well. There are certain OS utilities that you can make use of to check how many dirty pages are there in the page cache. You don't have any Linux, RHEL, or any. These are all third-party tools, guys. So for practicing purpose, you can basically use them. If you are using RHEL 7.4, you can use what you call VM Touch utility. And if it is, if the kernel version is after 7.4, the VM Touch utility does not work. You need to rely on other utilities. So you have to remember that page cache can also hold dirty pages as well. So I'll put it in a different sense. You have the buffer cache here, which is maintained using a sophisticated LRU algorithm, least recently used algorithm. You already cache the blocks which are frequently used only in the buffer cache. Then why do you require an additional cache here, additional page cache? Why do you require the blocks to be blocks to be stored in the page cache? Instead, you can increase the buffer cache altogether. If you are disabling this particular parameter, or I'll put if you are disabling the use of page cache by setting this parameter file system IO options to either set all or direct IO. Only if you have this parameter set to direct IO or set all, only in these cases Oracle can, Oracle will, can is a weak word, so I'm going to use a strong word here. Oracle will disable the use of page cache. So increase the size of your buffer cache when you are setting this file system IO options to from none to set all or direct IO guys. So I'll put it in a different sense. Under normal circumstances, you will end up having these blocks cached in the page cache. So we don't know how many of the blocks are basically cached unless you use utilities such as vmtouch, etc. So when a session is issuing an IO request, these blocks can be satisfied. This IO request can be satisfied from the page cache itself. So when you are setting this file system IO options parameter from none to set all. So set all is the recommended value, guys. Set all is the recommended value. Don't use direct IO only. Direct IO, that all the IO requests will become synchronous only. This will reduce the performance of your index range scans or even the full table scans as well. So don't set it to direct IO, set it to set all. Set this parameter to set all. Depending upon the type of the Oracle operation, Oracle can make use of, Oracle will make use of both as well, asynchronous and IO and direct IO as well. So you have to remember, set it to set all only. Now, regardless of the index scan or full table scan, Oracle, the Linux always, the operating system always caches the data, guys. So you need to remember one thing. So if I am setting this to set all, so let me show you here. So I have the database environment already running, working, everything. So now I don't have significant load on my disks also. The disks are almost idle. Due to the fact that the data is present in the page cache, I'm reading the data from the page cache. Now, you see certain recommendation and then gives, and then basically you decide to set it to set all, alter system set, file system, IO options to set all, scope is equal to SP5. Now I'm going to restart this database, guys. Startup force. Now, once the database is started, what I'm going to do is I'm going to run the same workload again. So here, in this case, I'm going to go with the index scans first and then show you the behavior. So I'm running the index scans workload now. Can you see the increase in the disk utilization rate, guys? Because due to the fact that you are not relying on page cache anymore and you are reading the data from the disk, your disk utilization will always be high. You are reading the data directly from the disk, not from the page cache. So when you are changing this parameter, when you are changing this particular parameter from none to set all, always see the size of your page cache. Always see how much amount of memory is allocated in the page cache. You can use utilities such as VM Touch to basically see precisely how many blocks related to a particular file are also cached. So I'm talking about file system based, wherein you have the data files on file system, not on ASM. If you have ASM by default, the page cache will not be used. Page cache will be skipped altogether. So I'll talk about that in a later session. So you need to remember that if you have the data files on the file system, then only the file system IO options parameter actually comes into the picture. The be it regular file system or XFS or even NFS as well, whatever it is. So even if you have NFS, repeatedly read blocks will be present in the page cache. So even if you have NFS, the blocks will be cached in the page cache as well. So you have to understand that. So I'll talk about NFS in the greater length when we come across this particular thing in the later sessions. But for now, just remember that if you are changing from none to set all, always make sure, always see if you can increase the size of your buffer cache. See if you can increase the size of your buffer cache. If you are not increasing the size of the buffer cache, then you will end up seeing significant IO activity due to the fact that previously the blocks were read from the page cache before. Now you are, due to the fact that you are disabling the use of page cache altogether, you have to mandatorily read the data from the disk. So this can lead to significant increased utilization at your disk level as well. So when you are setting it from none to set all, so if the database is brand new and if there is no workload going on, then directly go and set it to set all, guys. If you have a database wherein the OLTP workload was running for quite some time, then check the buffer cache advisory to see if an increase in the buffer cache can help. And also, if you have suppose a 4 GB or 5 GB of page cache, then increase the buffer cache altogether, size of the buffer cache altogether. So otherwise you will end up seeing more reads. You will end up basically making a mess here because you are reading the data directly from the disk itself. So let me just show you here from a different angle altogether. So I have set the file system IO options to set all. So now I am basically reading the data from the disk. So let me see how many executions I am able to attain for every second. Can you notice at least 200, only 200, 300, right? Everyone? Every second?
Yes. Yes. Yes.
Now I'm going to set it to set all, alter file system IO options to none. Scope is equal to SP5. Finally, start of force. I'll restart the database. So we know that if we set this parameter to none, I end up using the page cache. So now let's see the same activity, how many executions per second I can achieve. As soon as my data gets cached, let's wait. Let's wait. So can you notice a significant increase, guys? 400, 1000, 2000, 3000 executions a second. Can you notice, everyone?
Yeah.
So you have to remember, guys, when setting this parameter from none to set all, try increasing the size of the buffer cache. Increase the size, or not try, basically increase the size of your buffer cache. If you have, due to the fact that most of the blocks will be present in the page cache, things can get really ugly. And moreover, let's move on to a direct IO, guys. So This is not recommended. Yes, I don't recommend setting this value. Either set the file system IO options to none or set all. Don't go with these particular parameters. So there are many legacy DBAs or ancient DBAs who actually, yes, there is, if you set it to settle and then make use of asynchronous IO, there is always a case for corruption. Yes, but then most of the issues are gone and the hardware is more robust now. The chances are you encountering the corruption is way less, way less. So when we are talking about the indexes, you will see the significance of this particular parameter. You will see the significance of this parameter when we are talking about index scans, index range scans or skip scans or whatever it is. So direct IO was introduced as part of the kernel 2.4 base. This was there for a very long time, and moreover, if you enable the direct IO, you would see the sessions reading the data files using this particular flag O underscore direct. So this flag will be set. All the read and write operations will be synchronous only. There is no scope for using the asynchronous IO. All the IO calls will be made using pread or synchronous IO calls only. The two pread 64, write 64, read, write, and all those things. So careful while switching, guys. Again, consider setting it to none, from none to set all also. You are effectively disabling the use of the page cache. Check the size of your buffer cache and increase it accordingly. Otherwise, you will end up reading more blocks from the disk or indirectly increasing your disk utilization rate on the server. So if you are using ASM or OCFS or OCFS2, direct IO is enabled by default. Direct IO is enabled by default. So the direct IO is always slower than asynchronous IO because your process ends up waiting till that particular block is read from the disk. So it is always slow, guys. So don't go with this particular option. Either go with none, just leave it to the normal value none or set it to set all. None or set all. So my recommendation, depending upon the workload, I can just leave it for none, or if I have, I can even go with set all as well. So I'll talk about these things in depth. For now, just to remember that making use of setting this parameter to none, you use the page cache to the full extent, and this page cache can also have dirty blocks. Setting it to direct IO or set all will skip the page cache altogether. So you will not rely on the page cache anymore. You will end up reading the data only from the disk. So if you are trying to change this particular parameter from none to set all, consider increasing the size of your buffer cache, because previously the read requests may be satisfied from the page cache, due to which the throughput may be higher, but now due to the fact that you are disabling the use of the page cache altogether, you have to eventually read the data from the disk, and the disk IO will usually be slower than accessing the data from the memory. So you would end up seeing reduced TPS at the application layer as well. Transactions per second, or APIs per second, whatever you call it, whatever the metric they call it. So always always check the size of your application. Finally, so once you set it to set all, Oracle can make use of asynchronous IO. So remember guys, even the database writer can make use of asynchronous IO. Even the log writer will make use of asynchronous IO. I'll talk about log writer when we are dealing with log file sync, log file parallel write wait events. I'll show you the exact behavior, how file system IO options can help increase the performance. So suppose say I'll put it in a different sense. I have 3 log files in a particular group. We know that when you commit, the data is written to all these 3 log files. Yes, but if you are using synchronous IO, you have to write it to this file first. You have to wait until this file data is written to this file. Then you will end up writing to this file. Then again, you have to wait till the write is completed here. So if you use asynchronous IO, what happens is that the log writer issues a single IO call, IO submit call, to write the data, write the contents of your log buffer to all these members in a single IO call itself. So this can also help increase the throughput of your application significantly. So indirectly, if you have more write activity, as enabling the asynchronous IO, due to the fact that log writer can make use of the asynchronous IO calls while writing the contents from your log buffer to the disk using a single IO call itself, things will be way faster. Things will be way faster. So that is one thing. Even the database writer, while performing an object level checkpoint or incremental checkpoint or full checkpoint, or even periodically it writes the dirty blocks to the disk. So due to the fact that a few of your sessions may be bringing blocks into your buffer cache, and then if the space pressure increases, even in those cases also, I mean, the database writer can write the dirty blocks to the disk. So while writing the dirty blocks to the disk, DB writer can also make use of asynchronous IO. I'll talk about these things in the next session. So it will help the database writer also. So I'll explain that how it actually helps when I'm talking about NQ fast object checkpoint, NQ fast object checkpoint, or object level checkpoint that happens just before initiating the direct path read. So for now, just remember that if you set this parameter to none, you end up using page cache. If you set it to set all, Oracle, depending upon the activity, can make use of either the direct IO or asynchronous IO as well. But due to the fact that you are enabling the processes, I mean, no, asynchronous IO is not just used by your server process or the user sessions. It will also be used by the DB writer and log writer also, which will help increase the performance significantly. So disk IO, async IO is basically the master switch case. If you set this parameter to false, and regardless of the value of this particular parameter, Oracle will always make use of synchronous IO calls only. So asynchronous IO calls, you will end up seeing IO submit OS calls. So my recommendation, honestly speaking, go with set all, guys. Go with set all. So that's it for today's session, guys. Tomorrow we'll deal with the other stuff. We'll talk about many things. We'll start with the wait events, DB file scattered read, the direct path read, and cases wherein things get really slow and everything. So that's it for today's session. Do you have any doubts?